So I came across this video by Unit of Time, which I highly recommend, link in the description. And inspired by that, I decided to have a go at writing an entity component system in TypeScript. Now, TypeScript probably doesn't need an entity component system because one of the big selling points is that it's for performance and cache misses and stuff like that. But we're just doing this as a learning exercise, so it doesn't really matter. But I did run into some really annoying problems with TypeScript's type system. So I have this component class here, and the intention is that any component in my system is going to have to extend this class. Now this class supports JSON, which is intended to mean that it is serializable. But there's a bunch of problems with the way this works. So if we take a look at this interface, all that it requires is that you implement toJSON. And what I'd really like for it to do is also require that you implement a function called fromJSON. But you can't do that because the problem with static methods is that they're declared as a property of the constructor object, I guess, and that they don't get built when you instantiate the object. JavaScript's weird, so you can't do that. So how do we enforce static from JSON is implemented for every class that extends component? Well, a sane person at this point would go, let's rethink the design of this type structure. This is obviously not going to work, but I thought, hang on, all we really need is a red squiggly line to remind us to do that. So can't we achieve that in Visual Studio Code? And it turns out it can be done by implementing a TypeScript plugin, if you have a lot of time to waste on it. So let's take a look at what the plugin actually does. If we have a look over here in my components folder, these are all the objects that are going to be extending this component class. Let's jump into the health class. It's quite small. All it does is it has a level and a capacity. The capacity is like your max health, and the level is your current health level. And then it has a bunch of utility functions to get at those and change them and transfer them between buckets. And down the bottom here, we have our two implementations, toJSON and fromJSON. But what happens if we don't have them? So I'll get rid of them for a second. And as you can see, we have a TypeScript error. The first TypeScript error we get is non-abstract class health does not implement an inherited abstract member toJSON from class component. Right, well, that's a basic TypeScript error. Let's fix that, and then we'll come back to the second one. So I'll turn that on. There we go. We now implement a toJSON. And we're left with one more error. So the class implementing supports JSON must implement a static from JSON function. So this is where the plugin comes in. This is basically impossible using vanilla TypeScript, but we've been able to get this warning. So if I come down here and I re-enable this static function, which does the deserialization, health is now happy. Now there's one extra feature that I built into the plugin at the same time, and that is that it takes a look at the toJSON function here, and it tries to figure out this type property here. What I really want for deserialization is to rely on the fact that this type property is a string which matches the name of this class health, so that I can have a list of classes and deserialize them. But there's no way in TypeScript, again, to implement that constraint. It seems pretty straightforward. I tried it. I can't find a way to do it. But we have successfully done it with a plugin. So now it says return value from toJSON should have a string literal type property matching the class name. Found health, but it should be health. What's cool about this one is because it looks for the declaration location, it doesn't actually need to be inside the, like you can have an indirect x equals that, and then you can return x, and it's still happy, and it will still do the check. So if that's wrong, there we go. It has to return something that matches the class name. And it can go even further back. It can go const, n equals health, and we can put n there, and it's still valid because it's still a type, a constant literal, which matches the name of the class. But if we change this to let, now it's a string, so it's not happy with that. It says it has to be a literal value, which I think is pretty cool. So now I can change the name of this class and rest assured that my deserialization code will have a whinge at me because I didn't update it to match the new class name. Rightio, I'll collapse my source directory here, and you'll see that there's another directory, ts_plugins nick over here. And inside that is a new package.json and a second source directory over here. Inside the source directory there's an index.ts. If we open up index.ts, which I already have over here, and let's zoom out a little, it's not easy to build plugins. They are pretty full on. And I wouldn't have been able to do this without significant consultation with ChatGPT 4. Not because I needed the AI, but because it's really difficult to search for help for this kind of thing on Google because no one does it. So there is barely any links or Stack Overflow discussion about how to do this. So ChatGPT 4 actually really sucked at this, but it did point me in the right direction a number of times and just gave me hints like the function names to use and stuff. And so we got there in the end. So let's just have a spool through this code and see what it does. Up at the top here, I'm just importing some utility functions that I created, and I might talk about those later, but they're not very important. Here we're defining a type. I'm not sure why it's defined this way, but that was the example code that I managed to find. And then we have some utility functions. So the first one here is unused, so I'm not going to talk about that. Let's collapse it. The second one here is get interfaces implemented. So what this does is it takes an instance of the TypeScript server, the TypeScript type checker, and a class declaration node. So we're basically working with the abstract syntax tree that TypeScript gets sort of passed into before it's recompiled into JavaScript. And this node here represents a class declaration. So we basically go class declaration, heritage clauses, and then we map over those and we see if the heritage clause is an implement, like a implements interface clause, or in this other branch of the if statement, we look at the extends clause where you extend another class. So if it's an implementation, it maps over the types and returns a list of the type expressions. So that would be like if it implements supports JSON would be the type returned by this heritage clause.types. In the other case, it's a class, so we actually want to climb up the inheritance chain. And so this is basically just a big chunk of code to do a recursive call. It looks at the definition of that class to see if that implements the supports JSON interface. Down here, we actually have the beginning of the plugin, which is this is the object that actually gets exported from this module and what TypeScript thinks of as the plugin. So what the create plugin object expects is for us to create a factory function which returns a new instance of the TypeScript language service where we have patched the functionality of some of its functions. So over here, there's a return statement, and we're returning an object with a create function. And this create function is the thing that's going to patch the language service. So if I collapse a little bit of the stuff in here, hopefully we can see that inside create, we pick out the language service from this info object. We create a proxy of it, and we are going to replace the get semantic diagnostics function. And then over here, we just use deconstruction to copy all of the elements from the previous language service object and the object that we've patched from the proxy. So let's take a quick look inside this get semantic diagnostics function. It takes a file name, and we basically do some preparation work here where we ask the language service to get the semantic diagnostics. We return the result. I don't actually understand this code because I didn't write it. But the basic part is that afterwards, we do this bit where we do a recursive visit to each child node within the file and do some checks. So in here, we check if it's a class declaration as the first step, and we save a reference to the visiting class declaration. So that has the type TS class declaration. And then we can do whatever we want to check it. So in here, we check if the class implements the supports JSON interface using the utility function, which I showed from before. And if it does, then we do all of those things. So we add those diagnostics. So this diagnostic here is checking that the from JSON function is implemented and that it's static. So you can see here that it looks for a method declaration where the name is from JSON, and it checks that the modifier flags include TypeScript modifier flag static. And if it's not, it gets the node, the visit class declaration. So that'll be like the name of the class at the top of the file. Just demonstrate that again. So if from JSON is missing, it puts the squiggly line there on the class declaration. The next bit here checks that the toJSON implementation exists, and if it does, it goes into a bit more detail. So it will look for the initializer of the type attribute of the returned function, and when it finds that initializer, it will attach a red squiggly line if it's not the same as the name of the class that we're visiting. And there's another diagnostic here where if it's not a literal type. I'll just quickly show you the process to compile this. Basically, you change directory into TS plugins nick, and you go tsc, it's npx tsc to compile. Then we change directory and go up, and we go yarn add dev, and then you install it as a local development package, like so. Stuff. Now that it's installed, you have to make sure that it is written into your tsconfig file in your top level directory. So I have it here, name ts plugins nick. Now I think in the past it may have been possible to not have to install it, and you could just go /ts plugins nick, so to like use this folder here. But this has been specifically patched out of the TypeScript server because it's a security hazard or something. So it's never going to look into this TS plugins nick folder. It won't work. It must be installed inside this node modules folder. Another quick thing to look out for is that you are using the TypeScript server, which is local to your project. So TypeScript, select TypeScript version, and then use this one here, the node modules one, which is local to your project directory. Once that's done, you press Ctrl+Shift+P and then type restart TypeScript server, and that's it. You are absolutely going to want to use the debugger while you're working on your plugin. So the way to do that is to set up the TypeScript server in VS Code into debugging mode, and you can do that by setting this environment variable. I believe this is the port that you need to configure in your debugging tool to connect to. There are two modes, so I think this one here with the BRK on the front makes the TypeScript server stop and wait for you to connect your debugger, which is useful if your plugin does something on startup when the server first starts. And the second one will just let you hook in the debugger whenever you feel like it. Then in order to debug it, you can use Google Chrome and type chrome://inspect and hit enter. That will bring you here. You should see the remote target here and then be able to click inspect, and that will bring up a debugger. You can insert debug statements into your code. So I have one somewhere in here, debugger. So you need to insert those into your code to make the debugger stop at those points. Would I recommend that you do this on your project? No. It took me like 2.5 evenings of messing around to get this TypeScript plugin working. It was unreasonably difficult, very badly documented. I think it's very cool, and I'll probably do it again, but I'll really think hard about whether it's worth it, because yeah, I gave up 2 days of progress on this actual game project to mess around with the TypeScript type system. Not really the best outcome. But anyway, thank you very much for watching, and I'll see you next time.